This screencast will be looking at the chemistry involved in stars. To do that, we need to understand what stars are. So, in the most basic sense, stars are massive spheres of burning gas. They are born from clouds of dust and gas in space called nebulae, and they come in various shapes and sizes, colors and sizes. They are composed mainly of hydrogen, some helium, and very small amounts of other heavy metals. According to modern estimates, our sun is composed of 71% hydrogen, 27% helium, and 2% of other heavy metals. Next, we're going to look at the structure of the stars. Okay, so first we have the core. The core is an extremely dense ball in the center of the star. It usually will take up about 50% of all the mass of the star, but only takes up about 1.5% of its actual size. The core is where the nuclear fusion takes place, and it is next we have the radiative layer, which is full of hydrogen and helium nuclei ions, which are basically hydrogen and helium nuclei, and also full of unbound electrons. This mixture of ions is usually called, it can also be called plasma. Sometimes it's also considered a fourth state of matter. In the radiative layer, also helium 2+ ions attract electrons to form helium+ ions. In the convection layer, there are also convection currents, hence the name convection layer. These are movements of hot versus cold, or hot versus cooler atoms that are moving around within the layer, with the hotter atoms rising up towards the outside and the cooler atoms staying moving down towards the inside of the star. Next we have the photosphere. This is the visible colored surface that we see on the sun, mainly composed of gas and hot atoms. Next up is the chromosphere, which is basically the lower atmosphere of a star, and then the corona, which is the outer atmosphere of a star. The corona also has a strange fact. It's the hottest part. It's the second hottest part of a star, even though it is furthest on the outside of a star. So how do stars produce light and energy? Stars produce energy by nuclear fusion, a process where two nuclei collide together with enough force to combine and to form one new nucleus. So the main way that they do this is using hydrogen. This is the general equation for nuclear fusion. 4 helium atoms combine to form one. This is the general formula for nuclear fusion. 4 hydrogen atoms come together to form one helium atom, 2 positrons and 2 negatrons. What makes the actual energy out of this is that 1 positron and 1 negatron together form energy and release huge amounts of energy. Other reactions that can happen once the hydrogen runs out are helium, which burns to form either carbon or oxygen or neon, mostly carbon though. This happens at around 20 million degrees Kelvin, and then once what also can happen is carbon burning, which can burn to produce magnesium, sodium, or neon, and also a myriad of other reactions that can occur to form helium, magnesium, oxygen and magnesium, silicon, titanium, and many other things. here I have a picture to show the aging of a star. So the first thing that it burns is the hydrogen, which then becomes helium. Then helium burns to form either carbon or oxygen. Then carbon can burn to form either neon or magnesium, and oxygen can burn to become either silicon or sulfur. Silicon and sulfur then can burn to become iron. As you can see here, these are the shells that form by each of these different shells that in which the different elements are contained. And that is it for this presentation. Thank you for watching. Goodbye.